This video introduces decision trees. First, a quick review of the models we know. We know to use a linear regression model if we're trying to predict or understand a continuous outcome, something with a range of values. We also know to use a logistic regression if we're trying to predict or understand a binary outcome, something that we want to classify into one of two buckets. But what else is there? What if we violate the assumptions of either one of these models and we can't fix those issues using bootstrapping or some other technique? Are there other options? Yes, there are. One of these very flexible options that comes from machine learning is called decision trees. A decision tree is a list of rules for systematic decision making. So essentially, the scientist, you, creates a model that will help us to remove the human decision-making factor from making a decision. Why is this important? Well, we need something that will look at the data and make a decision. And linear regression and logistic regression do exactly that. But this is going to be a more flexible model that's constructed in a completely different way to do something similar, but under different circumstances. A statistical decision tree is just a list of rules for making observations part of different groups based on their characteristics. So essentially, you're saying if this observation appears to be similar to these where we made this decision, then let's make that decision again. It can handle a logistic regression problem, which would be called classification, or it can handle a linear regression problem, and in this case we would call that a regression. So it can handle two different types of problems, classification and regression, and that's already one unique characteristic that we didn't have in other models. It can handle different types of problems. It's often referred to as a classification and regression tree, or CART, for this reason. It can handle many different types of situations. So let's do a quick review of the anatomy of a tree so that we can know how to talk about these things as we're developing them. This is an example of a tree, and you see in the gray boxes different yes or no decisions, and in the colored boxes you see different decisions as a result of satisfying some of those conditions. So the gray boxes and the colored boxes are also called nodes. These are locations in the tree where decisions are made. The top of the tree is called the root node. This is where all of the data starts at the beginning. Each node can be a parent node, and if it is a parent node, then it will have two children, exactly two. Every node has exactly 0 or 2 children. There's no 3 children nodes from a single parent. And the colored boxes I've made colorful just so we can identify a difference between them and the others. These are the decision nodes or the terminal nodes where you get to sort of the bottom of the tree. The gray boxes contain splits where we decide, does this particular observation satisfy a yes or a no here? And those are splits, and each one has a variable in it that we will split on. There are also split points in some of them. So we split on the variable income at the location of $40,000. If a particular person makes more than $40,000, we would call that a yes. If they make less than $40,000, we would call it a no. And that person will get categorized into two different locations if he or she satisfies one of those two things. If that person makes more than $40,000, we'll say that's a yes. They'll go to this node, and we will decide based on whether or not they have children, whether we expect that we're going to get a donation from them or not. If the person makes less than $40,000, we'll send them to the age bucket and make their decision based on age. The split point is that $40,000 where we're making that decision. Let's look at some examples of classification and regression trees. So on the left-hand side, we're going to look at whether we receive a donation from a particular person. And that tree is the one we saw on the previous page. We're going to make different decisions about where that person will end up as a yes or a no based on certain variables in their background. For the regression tree, we're going to answer the question, how many hours will it take to deliver these packages? And we're going to design that tree to essentially yield one of a continuous set of outcomes. So maybe it depends on the number of packages that we're going to deliver that day, how many are oversized, what the weather was like, and the predictions might fall into different buckets like this. Maybe we predict 4 hours for all days of certain types, where the number of packages was not more than 11 million and the number of oversized packages was not more than 15%. Maybe we're going to predict 8 hours for a day if other conditions apply, or 12 hours. So we're still putting things into buckets, but we're assigning a numerical prediction. So you can see how two different trees can answer two different types of questions in two different types of ways. This is just your basic introduction to give you an idea of what a decision tree might look like. When we're using big data and we are trying to make a set of predictions based on just an inordinate amount of data, these trees will get exceptionally large and we will get less and less information just by looking. We'll have to evaluate them in the same ways we've evaluated our linear regression and logistic regression models based on error distributions and confusion matrices.